is a moment's question from one of the CCEA past papers. This is actually a practice paper. I think it's from September 2021, and this then is question 5. So let's take a wee look then at what's being asked. Uniform ladder AB of mass 40 kilograms rests with A on the rough horizontal ground and then B against a rough vertical wall. End A is 1.2 metres from the wall, end B is 4 metres from the above the ground. Two of the external forces acting on the ladder are shown below. Complete the force diagram below. So what else are we going to have to add in here? So we know obviously these two are acting here. It's a uniform ladder, so halfway along we're going to have a 40G acting here, and effectively the same thing going on up here as we have down here. So see the way they've labelled it in the mark scheme, they've called this RB and they've called this FB. I think it probably makes more sense. And then RA, normal reaction here at A, and my friction then at A as well. And notes we know this distance, that's 1.2, and we know that's 4 as well. By taking moments about A, show that 10R plus 3F equals 60G. This is one of these unusual ones. Quite often we kind of find this distance here and then resolve like this, but this is a different scenario where because we're given this distance and we're given this distance, it's actually more convenient to do it a different way. It's just really by definition of our moment, because our moment is the force times the perpendicular distance it is away. So clockwise about A, let's see if we can see this. We have the 40G, so if people sort of struggle with it, I sometimes tell people to put the pin in there. That's taking it clockwise. The 40G is taking us clockwise. The RA and the FA have no effect. The RB takes us anti-clockwise, and the FB takes us anti-clockwise. So it's clockwise equals anti-clockwise. So it's going to be half of that. You see the way that 40G comes through and it cuts at 0.6. So the perpendicular distance away is 0.6. So it's 0.6 times 40G equals that F. Where's its perpendicular distance? It's actually 1.2. Again, you can see that. There's the perpendicular distance if you extend that FB from there. So it's FB times 1.2. And then this RB is actually then, that distance is 4. So 4 times R. So starting to tidy things up, 0.6 times 40 is going to be 24G equals 1.2. I'm just going to change that to an F, which is a bit silly of me here, but that's okay. It'll get us what we need here. So we can see then what's going on. I think we're kind of quite close. So I'm going to times through by 10 to get rid of this fraction, and we'll see what happens. 240G equals 12F plus 40R, and then everything divides by 4. So we should really do this in the next page. Let's move it on around so we can see where we're going from. Dividing everything by 4, the 240G divided by 4 of course gives us 60G. The 12F gives me then 3F, and the 40R is plus 10R, and that's what we've been asked for. The coefficient of friction between the ladder and the wall is 0.4. The system is in limiting equilibrium. Find the value of F. So we know from our formula that F is mu R. So we know our F in this case is 0.4 R. And if you want to rearrange it, then you get times through by 10, 10F is 4R. You actually get 2.5. It's just handier for us to kind of work it out. 2.5F equals R. If we combine this then with what we just worked out earlier, so we're going to sub this in. $60G equals 3F plus 10R. 60G equals 3F, so 2.5 F is our R, so we're timesing that, so we're going to have 25 F, so that means 60G is 28F, and once we divide that, so 60 times 9.8 divided by 28, we get 21. We have that. Find the coefficient of friction between the ladder and the floor. So again, using what we've worked out F is 21 newtons, and again we're sub it back into G minus 3F, which is about 6 upon 21. That means 10R is 60G minus, what's that, 63. And I think R then gives us 52.5 newtons. Again, just stick that in there. So 60 times 9.8, take away our 63. We think that works us out. We're now going to resolve horizontally and resolve vertically. That's all we ever do. With these questions, generally you can nearly bet your house that you're going to take moments about somewhere, and then everything going left equals everything going right, and everything going up equals everything going down. So resolving horizontally, what are we going to have? We're going to have RB equals then our FA. And we've just worked out that our F of A is 52.5. And resolve vertically, so everything going up equals everything going down. F of B plus R of A equals 40G. So that's 21. Again, put that into your calculator, take a 21 over the other side. 40G is obviously 392. 40 times 9.8 gives me 392, so R of A then is 71. And then, so down at this end then, friction equals mu R. In our scenario, we have F of A mu times R of A, so we have 52.5 equals mu upon 371, and gives us a value for mu then as 0.14.